Can I copy that? Cool. And now, in this final step, we're going to solve the whole equation. So, let's go ahead and take our ODE and write it out without all these ones in the middle of it. Dog, I need some space right now, please. 4xy squared minus 4 sine of x plus 2e to minus 3y e to x dx plus 4x squared y minus 6e to minus 3y e to x dy equals 0. And I'm going to grab the m and n as well. And then I'm going to move this all to the next page so that we can kind of see everything all together. One thing that's nice about sort of being on a board, although my handwriting is much worse at a board, is that there's a lot more space for stuff. So, now that we've got this so that we know it's an exact equation, we can go ahead and follow the steps to solve it by sort of integrating our m, solving for our unknown g, and then saying that that must be what our f is. So what we're going to do is we're going to say, okay, we're going to solve some f equal to c, where f is the integral of m with respect to x, except for maybe there's some unknown g of y in it. And our m is that 4xy squared minus 4 sine of x plus 2e to minus 3y e to x. We're integrating all that with respect to x. And then there's that unknown g of y. That's our unknown constant as far as x is concerned. And so let's go ahead and just evaluate that integral. The integral of 4x is going to be x squared divided by 2, so that 4 becomes a 2. X squared times y. The integral of sine is minus cosine, so this is just going to become a positive 4 cosine of x. And then e is unchanged by integrals when it's just regular e to x, so it's going to be plus 2e to minus 3y e to x. And if I don't get the right answer when I plug this in, we'll go ahead and check my integral, because there's always a chance that something went wrong there, like I forgot to copy down the squared on my y. So at least I caught that. But everything else looks okay to me. We'll see how it goes. So that means that my g is going to be that f minus all that stuff right there. Or that g prime, which is a function of y, is going to be n minus the derivative with respect to y of all that stuff. So my n was 4x squared y minus 6e to minus 3y e to x. And then I want to subtract the partial derivative with respect to y of that quantity I just integrated. 2x squared y squared plus 4 cosine of x plus 2e to minus 3y e to x. So I've got 4x squared y minus 6e to minus 3y e to x. And then I'm going to leave everything in brackets but do the derivative, and then I'll do the subtraction in the next step just in case there's any mistakes. So partials with respect to y here, I'm going to get 4x squared y from that first term plus 0, because the cosine doesn't depend on y, minus 6 e to minus 3y e to x. I think that looks right to me. And when I subtract, I can see that this thing inside is the exact same as this thing outside. So I'm just going to get 0. It'll be like 4x squared y minus 4x squared y minus 6 e to minus 3y e to x plus, distributing that minus sign, 6 e to minus 3y e to x. So if g prime is 0, when I try to solve for g, should be a bit more clear. That's an integral with respect to y. Integrating 0 with respect to y is just going to give me a constant. So kind of, there is no extra g term that we're going to have to add here because it's going to get eaten by that constant on the left side. So let me grab my f that I had. Oops. Not so good with the lasso right now. Okay, I need to copy that and paste it. So that's my f. And my g is just a constant. So my f is actually 2x squared y squared plus 4 cosine of x plus 2 e to minus 3y e to x plus c. And I'm going to set that equal to some constant. I'll call this one c1, this one c2. But altogether, it's just going to be some random constant on the right side. So I'll have 2x squared y squared plus 4 cosine of x plus 2 e to minus 3y e to x equal to some c tilde, where c tilde is c2 minus c1, but we just lump them all together whenever we do this kind of problem. Let's check if that's right or if I have to go back and check all my integrals. And it is right. So we solved the problem. We would solve for this unknown constant in an initial value problem. If we were given like y of 0 equals 1, we would plug those numbers in to figure out what c should be. And then eventually you might want to try and write this as a solution for y, but you couldn't really separate these things, so we would have to have one of those implicit solutions where maybe you put everything that's y on one side, but it's still kind of not a y by itself equals the solution. I'm gonna check to make sure nobody else posted in the problem solving request thing before I hit end on this, although I did wait to check it until a little bit after 4 just in case, so we shouldn't have. And no, looks fine. And nobody came into the Zoom, so I'm going to go ahead and finish the recording, get this posted. Good luck on your homework tonight, everyone, and good luck preparing for the exam.